Today I'm going to talk about what are called Bauplänes. Now, Bauplan, or body plan, is something that I've had to talk about with a few people, well, more than a few people, with regards to integrated pest management and crop scouting. And the reason for it is pretty simple. Bauplan is just what you do, or rather it is what is the morphology of a pest, or really anything. Human Bauplan, tiger Bauplan, turtle, whatever organism we're talking about, usually with classification. So before we knew about genetics, right, we would classify things by their morphology, what they looked like. And that worked for a lot of things, but not everything, because evolution can be strange. And also for microscopic organisms, our vision isn't good enough to know what they look like without aid. This is for the same reason. This is the reason why, for example, fungi were considered plants for a long time, just a weird kind of plant, up until kind of recently when you think about human history, actually. But, a lot of organisms can and do look like each other, and they are related for, not for that reason, but you can deduce that they are related for that reason. You happen to be right with genetic testing and things like that to confirm that they're related. But with regards to integrated pest management, a Bauplan is really helpful as like a general guide to know what different pests are and what groups they fall under. You might not know what the species is, but you can use some of the stereotypical morphologies to articulate for yourself, oh, that looks like a mite, or oh, that looks like a stink bug. What species? You might not know. It might not even be recorded where you live. That happens. That happens a lot. And with pests, they get to places you don't want them to be all the time. So, knowing, for example, what something looks like instead of what it actually is can still be good enough for control. But you still want to find out exactly what the species is. So don't kill it, don't destroy it outright. Under most cases, I would say that it's really a good idea to capture it or capture a specimen and try to find somebody to identify it. So, for example, and my drawing skills are going to be used here, the Bauplan of a stink bug, for example, that's an adult, kind of has, they're called pentantomids. So a pentantomid has a 5-pointed body for the most part. And I'm going to kind of give a very sort of a very basic drawing here of sort of like a pentantomid body. That's not quite good enough, actually. But we can see we've got the points here. Right? So you've got points. You got 5 points. You got 1, 2, 3, 4, kind of the shoulders and the end points. And you've got the head, which is the 5th point. And that's a pentantomid, a 5-pointed bug. And typically those are called stink bugs, for example. But then what if you have something that's microscopic or close to microscopic, like a 2-spot spider mite or something like that, right? So those are harder to kind of discern. But if you can see through a microscope, you'll find that the head and the body are kind of fused. And they don't have antennae. So that's a really important part right there. So for example, if you have a mold mite, it looks like this. You've got 8 legs, and you've got big, kind of hairy setae, and you've got like a body with chelicerae, and you've got kind of eyes, but I'm not going to draw those. So you've got, for example, here, this is also very crude and rudimentary drawing, but a lot of mites, a lot of mold mites, a lot of organisms in that similar sort of group have these long hairs called setae, and they've got, as arachnids, they've got, or as acarids, they've got 8 legs. Nymphs don't, though. Nymphs sometimes they have 6, and or if we don't know, russet mites, for example, which I'll draw here, they have 2 sets of legs, so they've only got 4 legs. They don't have 8 legs. And they kind of look like this, typically. And they've got sort of a, not really a true segmentation, really, but they kind of look like this under the microscope. So you can tell pretty easily that the mold mite here and the russet mite here are not the same thing. And obviously the pentantomid's way different and way larger. But what are some other organisms? Well, I guess we could contrast, for example, a 2-spot spider mite from a mold mite and then maybe go into an aphid. That's a really common misconception or misunderstanding when somebody's looking at an organism. They'll think that it's an aphid when it really is a mite. And that's really easy to make a mistake about if you don't understand how big these organisms can get, or what the size is, the size category for different organisms. Aphid nymphs can be very small, but aphids that are full grown, they're going to be larger than any 2-spot spider mite you come across. Same for the mold mites. They're going to be much larger than those too. So for example, we've got sort of a basic outline here. And then we've got the ceca, which are the 2 spots. The 2 spots on a 2-spot spider mite. What you're actually looking at is you're looking at like part of the intestinal tract, like a food pouch, you could consider it. And sometimes they're absent because maybe it stopped feeding, maybe it's overwintering. There's a bunch of different reasons why that could be. So just because you don't see 2 spots doesn't mean that you're not seeing a 2-spot spider mite. But that's sort of technical, and this is sort of a basic organization about Baupläne. So they'll also be kind of hairy for the most part. And they'll have like chelicerae. Chelicerae are like the mouth parts of a lot of mites. Let me see if I can get myself to focus. Hopefully that starts happening. There we go. So yeah, this is also very basic as well, but those are pretty similar, aren't they? So the 2-spot spider mite's going to be a little bit larger than the mold mites, and they're also going to be found in different places too. So when you're coming across an organism that you recognize as an organism, but you don't recognize what it is, you can use some context clues to kind of figure out, even if something looks similar, is it really the same thing? Is it something different? How do you avail that? Well, you have to understand its physiology, and you have to understand its proclivities as a pest. So you're not going to find 2-spot spider mite in the soil, typically. I mean, there's always a possibility that you find one that's fallen or something like this. But generally speaking, you can expect to find 2-spot spider mites on the leaves, on the foliage of a plant. Many kinds of plants. Over 1,200 kinds of plants documented. But on mold mites, you're going to find them in the soil, you're going to find them in organic matter. So even if you do see 2 hairy mites, you're not going to see the exact same organism, and you might very well notice that the 2-spot spider mite is typically like a red color, but it can also be yellow or pinkish, and I have a video on that on my YouTube channel if you'd like to check it out, called Identifying Tetranicus urticae, the 2-spot spider mite. And it goes into detail about how different colorations don't necessarily mean that you're seeing a totally different organism. You have color morphs and permutations in a lot of organisms. Dark forms, light forms. Nutrition can play a part, just like how nutrition, being malnourished can make somebody look very different, just like how malnutrition can make a mite look very different. But for a mold mite, it's going to be usually white or cream colored, tan. It's not going to have the same coloration. It's not going to be found in the same place. The hairs are going to be a lot longer. If I showed you a picture, and when I upload this to YouTube, I will, I'm going to put a picture of a mold mite and a picture of a two-spot spider mite, and you can see the very obvious similarities, but also the very obvious differences. And if you marry that information with where you find the organism, then you can make a pretty good judgment call as to what you're actually looking at. Does that make sense? Hope so. And then, of course, so like, let me title these. But then, if you find a spider mite, you might want to know, well, what species is it? Well, you might not know. Tetranychidae, the spider mites, is a pretty big family, but the most common one people find is two-spot spider mite. So, it's more likely that you'll probably come across that than other organisms. But yeah, so for example here, you'll find the two-spot spider mite up on the foliage. You'll also find the russet mites up on the foliage, but the mold mites you'll find in the soil and the microbiome and places like that. Or I mean the soil microecology, those areas. So when you're looking at your organism, again, you have to consider where you found it, what you think it might be, and then what does the morphology tell you about what that is. And if that's congruent with what you think it might be, then it very well might be it. I appreciate the compliment, Siobhan. I'm trying to when I make these videos, the idea for them comes from my interactions with all of you, with people who ask me questions, and I get questions daily, multiple times a day, about different aspects and what is this. I've gotten a lot of pictures lately. I guess it's lady beetle season. I've gotten a lot of questions about pupa. The larva for a ladybug looks really different than the adult, obviously. So people will come across this sort of like what's sometimes called like an alligator. I guess biologists can be kind of weird about naming schemes. But yeah, so this is my there would be color and things like that. But like a ladybug, a lady beetle larva would be like all black, kind of like this. And it would look very different than a ladybug, obviously. So people come across it, and they don't think that it's a good bug. They think it's a bad bug, and they kill it, which is unfortunate because it's just a case of mistaken identity. Disco Dro, ladybugs do not hunt mites typically. There are some species that do, but not the traditional red and black spotted ones that you think of. Stethorus punctillum does, for example. And caterpillar eggs can sometimes be predated on by some ladybugs, but again, not typically the ones that you would see in a garden store or something like that. But then the pupa can look really weird. And let's see if I can even draw a really good example of one. This is kind of, again, very crude rudimentary drawing here. Yeah, that's good enough, I guess. So, here we've got like the pupa, and the larva turns into the pupa, and then we'll turn to the adult. And the pupa looks like this sort of hanging like mass, and it doesn't look anything like what you would expect a beetle to look like. But if you're familiar with beetle grubs, it looks like if you're familiar with beetle metamorphosis, then it looks very much like what you would expect. But most people aren't. So when they see this, they think it's a big problem or a pest, when it really isn't. It's just a bug that's going to help eat some of your aphids. And yeah, so that's all I wanted to go over, really. I'm going to quickly go over this and probably talk about this a little bit later. You can find this sort of information on my YouTube channel, Zenthanol, and you can find this video if you just caught the tail end of it, or you want to reference it again. You can also find it on my YouTube channel as well. So just to kind of bring that home, we have sort of right. So for the ladybugs, so here we've got the ladybugs here. You've got larva, pupa, and adult, and they look very different from each other. So you just have to be aware of what's going on in your crop, and you have to understand some of the body plans that you're going to come across. Some body plans will look very similar, and there's going to be a beneficial and a detrimental possibly, and you just have to know which one's which. So anyways, that's all I had to say. If you want to find this video, check out my YouTube channel. If you have any questions, please come contact me and I'd be happy to talk to you about them. Have a good one. Recently I picked this orange from a friend's tree, and I was looking at the whole sphere, and I came across these scale insects here. This is California red scale, which is known as Ondiella aurantii, the California red scale. And it reminded me of something that's very true with regards to pest scouting in general and residential crops, and that's that in general it can be very hard to come across pests and to look for them and to find every nook and cranny. I wanted to outline these here for people because it would be very difficult to come across. I even had trouble finding them after I found them the first time. But you can see that this orange is pitted. You know, this is the peel, obviously. This is my friend's orange tree. I don't know the cultivar of orange or citrus in general, but this is a very common scale. It's in about, I don't really know off the top of my head, but it's a pest of many different plant crops. Well, there aren't any other crops but plants, I suppose. But more importantly, what this reminded me of is how difficult it is to really scout. People who do this for a living, people who cultivate plants, they gotta scout. And if they don't scout, they don't know what their situation is in the crop. But if they do scout, they might not scout enough. Statistically, they might not take enough samples. They might take too many samples, and they might think that they're wasting their labor, which is possible if they're taking too many or too little. And there's no way to really know that until you start experimenting and doing that. There are some loose rules, but generally speaking, every cultivation space is different. And if somebody were to take a sample, let's say from an orange tree, and they only came across these 3 scales, and there's no other context, then you don't really know if that's a lot or a little for that area. You don't know. If you don't know what your treatment schedule is, you don't know what's been going on for the last few months, then you have no idea what this could mean. You can have an idea based on other contexts, but those might not be applicable to what you're doing in the here and now. And that's why this reminded me of that fact, because these are very hard to come across. They're easy to come across because they're in a lot of places, especially in citrus orchards, but it's hard to find these really small pests before they become a much larger population. Because here we have 1, 2, 3, 4, 5 here, and there might be a couple of others around this area. And these are female California red scales, and if you took a sample, in an orchard of 100, and you took a sample of 5 per plant, that would be quite a bit. But if in that whole situation you just happen to not pick the right samples, you just happen to not pick the right ones, and all of them were very small, but there were actually other samples that you could have taken that would have had many more insects, many more pests, and you just don't have that, then you have no idea, again, what's going on. So it's really important to take the right amount of samples, and even if you do take the right amount of samples, sometimes, statistically speaking, you'll just make an error in your judgment based off the sampling that you have. And that's kind of my little small rant about how important it is to crop scout, how important it is to do it effectively, and to respect that even in cultivation centers with people who really know what they're doing, they don't necessarily know, or won't necessarily get it correct 100% of the time. That's just statistics. That's not anyone's fault. That's just how sampling works. If you want to learn more about that, I have a YouTube channel and several videos on crop scouting and integrated pest management in general, and I would be happy to share them with you as well. But I just wanted to take the time to talk about these California red scales, Anadelia aurantii, and about how that kind of is representative of how hard it is, even for people who do this all the time, like myself, to I guess to accept the reality that scouting is tough and pests are everywhere, and you don't always get every single one, even when you're scouting effectively.